Okay, welcome back. So, since the equipment worked fine, I am going to continue to do the rest of these exercises in Mathematica. So this is my second tutorial, and so I'm going to start from question 3. Alright, now the next one is an exercise in logic. So it's a basic question, and so we need to consider or. This is or, and not. So this is what Mathematica uses for or, and not. Okay, so we're asked, determine the truth value for the expression P and, in brackets, Q or not R. When P, Q, and R take on particular truth values, respectively false, false, and false. Alright, so I'm going to do this one. Now again, I'll comment, this is question number 3. Okay, so I'm doing this in a new cell. Alright, now I'm just going to write P and bracket Q or not R. Alright, so there's the expression. Now if I press Shift Enter, I'll just get it back. Alright, and that's not very useful right now because I just want to show you that it actually does what it's meant to when you give P, Q, and R some actual truth values. Okay, so let me now include above that P equals false, Q equals false, and R equals false. Okay, I put the semicolons because I don't want those values to be given back to me. I just want to know the truth value of this expression below. Alright, well, I press Shift and Enter and I get false. Okay, now let's mix it up a little bit and see if we get a different value when we change the truth of, say, Q. Alright, so I've changed that to true. Let's see, it's still false. Okay, no surprise, right? Now, what if I do the same? Oh, that's why. Because P is false, so I want to get a different truth value. I would have to change P to true value. Alright, Shift and Enter, and now it becomes true. Alright, so that question is done. Next we will go on to do question 4. And that says, use the mod function to determine whether or not 9 divides into 129 with a 0 remainder. As in, divides into it perfectly. Okay, so this is question 4. Right, so I want to know, basically, what is 129 divided by 9? If it's not a whole number, then, well, the answer is no, right? So, it's not a whole number. So the answer is no. It doesn't divide, 9 doesn't divide 129. Alright, next, well, we're supposed to use mod, right? So, doing the same, if I use mod, I'm just calculating the remainder, the 129 modulo 9. Okay, so I'll calculate that. And I'll scroll down so you can see it. Well, it's got remainder 3. Okay, so that's that part done. Next question, is 129 a multiple of 3? Well, we can already see that it is, because 1 plus 2 plus 9 is equal to 12, which is divisible by 3. So therefore, 129 is divisible by 3. But all I have to do is write 129 over 3 and observe that that's an integer. Alright, it is 43. So the answer is yes. Is 129 a multiple of 3? Yes. Okay, let's do the next question, which is question 5. And let's have a look at it. Okay, this one asks us to add up the numbers from 1 to 8. That's what that means there. That's the Mathematica code for add up the numbers from 1 to 8. So I'm summing over j, and j goes from 1 to 8. Alright, so let's evaluate it. We get 36. Now, just so you see, 1 plus 2 plus 3 plus 4 plus 5 plus 6, 7 plus 8, well, that's 36. Okay, so that's exactly what we expect. And next, we're asked to calculate the sum from 1 to 12 of the squares, j squared. Alright, so let's do that. Well, I can just copy and paste what I've already got there. Copy, paste. Okay, and now I change this j to a j squared, which of course is j times j. Change the 8 to a 12 because I'm summing from 1 to 12. Okay, sure. Now let's mix it up a little bit. What if I were to sum from, say, minus 5 to 12? Well, then I'd change the beginning 1 to a minus 5 and then repeat, right? So there it is. Okay, now let's move on to do the next one. You can see it's about binomial symbols. Righto. So it says use binomial to calculate the binomial coefficient 5, choose 3. Okay, so I'll just write out binomial with a capital B because it's a function, and square brackets, and then I fill in what goes inside those square brackets. Alright, so 5, comma 3 is the binomial symbol. 5, choose 3. Okay, and we see that that's 10. Okay, then we're asked to do the same with the factorial function. Okay, so there's a formula for the binomial symbol involving factorials, and it goes like factorial 5, and we want to divide by product of two things, so I include a bracket. First multiplicand is the factorial of 3 in the denominator, and I'm multiplying this by, so here I've included the asterisks for multiplication. Now you don't have to do that, you can just leave a space, alright, but it's really quite visible when you put an asterisk, and some people prefer that, especially if you are accustomed to other programming languages. Alright, so I'm multiplying this denominator by 5 minus 3 factorial. Alright, now let's shift enter. Aha, what do you know, you get 10. No surprise. Okay, so those agree. Now next we are using part E. Well, that is probably another question above involving a sum. Okay, so to help you calculate the sum of the two binomial symbols when n is 11. Alright, so let's write out sum, and we're summing over the letter R. Whoa, R is black, so that means it is in memory. So therefore I will go above this and clear the letter R from memory. Alright, comma, I'll just leave sum R from 1 to 5. Sure, execute. Now it's a bright blue color, so it's not in memory anymore, and I can start to edit this. Okay, so I want to sum from 1 to n. Yes, I want to sum from 1 to n, but I want to sum binomial symbols. So I copy that and paste it here. Binomial n, comma, r minus 1. Now I'm just entering this part around my cursor. Okay, now I need a binomial symbol for the other symbol. So this is n choose r. Okay, Now I've got the two of these, and what am I summing? R goes from 1 to n. Yes, that's what I want. However, I need to sum from 1 to 11. So I say n equals 11 right there. Alright, now we're good. We can shift enter and execute that and see what we get. 4094. Okay, all good. Right, next problem. Okay, so this was question 6. And now we are up to question 7. Alright, let's get on with it. Now, this one is about defining your own function. So far we've seen a couple of simple built-in functions. Now, Mathematica, I understand, has over 5,000 built-in functions. So it's fairly handy to be able to check what programs you've built yourself against built-in ones. So this is very helpful to know how to build your own functions. Now, let's see, somewhere around here I have a book of, here it is. Alright, so this one is my book of choosing a name for your algorithm. Alright, so I bought this for 50 cents second hand, and it's full of lots of names. Alright, don't know if you can see it, but it's full of lots of names. That's very helpful for when you get stuck for what you need to call your algorithm. Alright, so let's just go with Carl. Now I'm choosing a lowercase function name here, so lowercase c, because I don't want to get myself confused with what is a built-in function. But that's just a personal choice. Alright, so I'm building a function of my own here, and I'm calling it Carl. Alright, so square brackets. Now, inside the square brackets, I'm putting x underscore, comma, y underscore. Now this is saying I'm building a function of the two variables x and y. Alright, now colon equals, and then I'm going to use module. Alright, this is a built-in function called module. So, square brackets, and in there, I want to say what things I want to use as local variables. Alright, so these are variables that I want to give values to inside my function, but I don't want them to be remembered outside the function. So for that you need module. Alright, so let's just put in p, comma, q. Alright, now I'm going to give p a value and show you that it won't be remembered outside the function. Okay, p equals 7. Now, it's a function of xy that I'm building, so I'll put x plus y squared. That's a very simple function. Okay, semicolon. Alright, so I built that function. I can press shift enter. Now it's in memory as the function Carl, so every time you call on it, it will square x plus y. Alright, now let's try it out. So Carl 3, 5. Now let's think about it. 3 plus 5 is 8, and 8 times 8 is 64. So I expect to get 64. Alright, shift enter, and I get 64. Very good. Alright, now, the question says, what are P and Q doing? Well, in this case, they're doing absolutely nothing. Okay, they're doing absolutely nothing because they're just getting stored locally. So why did I put them in? Well, to show you that you can use local variables. Because if you use, say, function, they could be global variables that you'd be entering. Alright, so here I'm putting in, no, what do I didn't want to do? Alright, so P is black, right? That does have a value. But that didn't really matter inside the function, did it? But what is the value? I bet it's the value true that we entered earlier. Okay, so let's just see. Yep, it's true. That's because we did a problem earlier in which we set that as having the value of true. So I'll clear the value of P now. And now it's bright blue. Very good. So it doesn't have and I can get rid of this. Okay, it now doesn't remember this p equals 7 inside the function. Alright, so it's good. Now I can use this as well. I can change this function, also I'll just say plus 7 right here. Sorry, I want to say plus p. Okay, so plus p, and I'll use the value of 7. So let's think about it again. 3 plus 5 plus 7, 15, 15 squared. I think that's 225. Yep, okay, there we go. Alright, and it still doesn't remember the value of 7. I've used it in there. So this is a way to build a simple function that you can use later on. Okay? Alright, so it's simple. Alright, let's do the next and last question for our session. Question 8. Okay, so this one is about sets. So I'll just explain. Curly brackets are commonly used to denote sets in mathematics. Alright, in Mathematica, a curly bracket, like what we see here, curly bracket minus 1 comma 7, curly bracket, well, this is actually an array, alright, like a vector. It's an ordered list of numbers or letters, and it's acting like an array, but you can nevertheless use these to do some calculations with sets, alright, as in set theory. Okay, so I'm going to enter these. A equals minus 1, 7. Alright, B equals 1, 8, 7, minus 1, 4. And just to show you what I mean, I'm just going to change what B is right here. And I'm going to include another element in the array. Let's just put in another 8. Okay? So, and I'll put shift enter right now. Shift enter, and what do I have? It just gave me back that array, right? Okay, but to explain what I'm talking about, in order to use this as a set, I need to write union. Union B. And now what's happened is it's chucked out the extra 8 that I don't want, right? Because sets have an element once in there, so it's thrown out the extra 8. Now this is acting like a set, and I can program with it as if it's a set just by applying union to it. Okay, so that's that. Now I'll continue and write the other items, the other sets, or arrays in this case. 1, minus 1, whoops. Okay, and R is 5, 7. Okay, yes, now what are we asked to do? We'll calculate the cardinality. Okay, cardinality is just how many elements are in these sets. Now, of course, cardinality doesn't have to be finite, right? Like the set of integers is not finite. It has an infinite cardinality. But it is what we call countable, right? It's countable because integers are in one-to-one correspondence with integers. So we can count them in that way. Okay, so we've entered those values, and next I'm going to check the cardinality of, say, B. Length of B. Okay, what's the length of B? It's 6. Right, now it's the length of this one, right? So if I wanted the cardinality of the set B, I would just use union inside the length function, and now I have 5. So the set B has 5 elements. Alright, next, whether or not we need to find out whether or not 8 is a member of B. Alright, so there's a function member Q. Alright, the big Q is for question. Member Q B8. True, so 8 is a member of the set Q, or the array in this case, as it's entered into memory. Okay, next question. Determine whether or not A is a subset or equal to B. Now I'm guessing subset Q A comma B. False. Alright, A. Well, perhaps I got it the wrong way around. Okay, so A, we can see this. If we're thinking of this as a set, it is definitely a subset of B, right? So I think I should probably put it this way. And now it says true. Okay. Righto, so next, calculate the intersection of B and Q. Alright, so this is just intersection B, Q. Okay, so that is the set containing -1 and 1. And you can see 1 and -1 are common in both, so that's good. Alright, we can do the same with union. We can take their union, set of all elements in B or Q. Okay, so this is the union down here. And next, we want to compute B set minus Q. Alright, so in Mathematica this is the function complement. And I think it's B comma Q. Alright, so this should be B without Q. Yes, that looks like B without Q. So we've thrown out the elements that are in B from Q. Alright, now we want to glue two sets together, and we can do that with the join function. Join B comma Q. Alright, so let's have a look. The join of B and Q is this array. Alright, remember it's an array, but we can turn it into a set by just taking the union, putting union around this. And now we have joined the two sets and taken the union of the result. Okay, so that's it for now, and I'll see you next time.